Hey everyone, and welcome. Today we're going to tackle something that sounds, well, pretty much impossible. How do you actually put a number on things you can't see or touch? We are diving headfirst into the theory of attributes, a seriously cool way to measure the unmeasurable.
I mean, really think about it for a second. How would you measure the link between, say, being an honest person and being intelligent? Or what about the connection between being a smoker and passing a tough exam? You can't just get out a ruler for these things. This is the big mystery we're going to crack today.
Okay, first things first. Before we can start measuring these hidden connections, we really need to get a handle on the two different kinds of data we're playing with. It all comes down to what you can and what you absolutely can't stick a number on. So on one side, you've got your quantitative variables. These are the easy ones, right? Height, income, weight. If you can measure it with a number, it's quantitative, simple. But then you have qualitative attributes. Think about things like being sick or being honest. You either are or you aren't. You can't be like 82% honest. And that is where our investigation really begins. Now, to investigate these qualities, we need a special language, almost like a secret code that lets us track them. So let's learn the basic vocabulary for talking about these attributes. It's actually pretty simple.
The core idea here is the attribute itself. It's really just a quality that a person or thing either has or it doesn't. It's a straight-up yes or no question. Are you a smoker? Yes or no. Did you pass the exam? Yes or no. That's it.
Okay, so to keep track of these attributes, we use this simple but really powerful notation. If an attribute is present, we use a capital letter, like A. If it's absent, we use a little Greek letter, like alpha. So if A stands for smoker, then alpha just means not a smoker. This simple little code, well, it's the key to unlocking everything else.
So we've got our attributes, and we have a language to describe them. The first massive question we can ask is this: are two of these attributes connected at all, or are they completely unrelated, living in separate universes? This is what we call testing for independence.
Now, this is the formal definition, and it's basically the golden rule for our entire investigation. All it's saying is that knowing something about attribute A tells you absolutely nothing new about attribute B. They just don't influence each other, period.
And this example makes it crystal clear. Imagine this. If intelligence and honesty are truly independent, then if you take a room full of honest people and another room full of dishonest people, you should find the exact same percentage of intelligent people in both rooms. But if you find way more intelligent people in one room than the other, boom, you've just found a connection.
But what if there is a connection? Is it a tiny, weak little thread, or is it a huge, powerful bond? To find out, we need our master tool, our secret weapon. We need a way to put a single, powerful number on the strength of that relationship.
And here it is, Yule's coefficient of association, or as we'll call it, Q. The best way to think of it is as a relationship score. It's like a meter that tells us exactly how strongly two things are linked, all the way from a perfect negative connection to a perfect positive one.
Whoa, okay. Don't let the formula scare you. You do not need to memorize this. Seriously, the only reason we're showing you this is to prove that our relationship score isn't just magic. It comes from a very precise mathematical formula that compares all the different combinations of our attributes.
So, what really matters is what the final number means. It's super straightforward. If Q is +1, it's a perfect positive link. If you have one attribute, you always have the other. If Q is -1, it's a perfect negative link. If you have one, you never have the other. And the magic number? 0. If Q equals 0, there is absolutely no link. None whatsoever. They are completely independent.
All right, theory time is officially over. We've got our concepts, we've got our secret language, and we've got our master tool. Let's put it all to the test and solve a real case. Is there actually a link between smoking and passing an exam? We're going to follow a super simple three-step game plan. First, we'll lay out all the facts, all the clues we know. Second, we'll use a little logic to fill in the missing pieces of the puzzle. And third, we'll calculate our relationship score, Q, to get the final answer. Let's do this. Okay, here are the facts of our case. We've got 1,000 students total. We know 400 of them are smokers. We'll call that A. We know 300 of them passed the exam. We'll call that B. And here's the crucial piece. We know that the group with both attributes, smokers who also passed, is exactly 120 people. So let's organize our data in this handy little grid to see the whole picture. We can fill this in step by step. Let's look at the smokers column, attribute A. The total is 400. We already know 120 of those smokers passed. So to find the smokers who failed, we just take the total, 400,
and subtract the 120 who passed. That leaves 280. Simple. Now look at the passed row, attribute B. The total there is 300. We know 120 of those were smokers. So the number of non-smokers who passed has to be the total 300, minus those 120 smokers, which gives us 180. We just keep going like this, using the totals to fill in every box until the whole puzzle is solved.
And now, for the grand finale. We take our 4 core numbers, the smokers who passed, the non-smokers who failed, and so on, and we plug them into Yule's formula. We run the calculation, and after all that, we get one single number. And that number is 0.
And what does a Q-score of 0 mean? You got it. Complete independence. We've solved it. Based on this data, there is absolutely no statistical connection between smoking and passing the exam. Knowing a student smokes gives you 0 new information about their chances of passing. Case closed.
And that's the real power of this method. It lets us go beyond gut feelings or stereotypes and use actual data to test for these hidden connections. It gives us a clear, mathematical answer to questions that otherwise just seem fuzzy and impossible to measure. It really makes you wonder, doesn't it? What other invisible connections are out there, just waiting for someone to measure them?